Hello, this lecture we are going to discuss about analysis of transistor amplifier using H parameters or using H model concept. As we know that there are three configurations of transistors: common emitter, common base and common collector. All the analysis can be made by using a simple concept, and that is a common concept, and that concept is nothing but hybrid model concept using or utilizing hybrid parameters. As we know that all the hybrid parameters are standard, these are the two standard equations which describe the hybrid parameters, which are V1 written in terms of V1 and I2. HI1 plus HRV2, HFI1 plus HOV2 is equal to I2. And this is nothing but the block diagram which I have shown here is a two-port network, and this two-port network is a device. Transistor is an example of two-port network. So we are trying to make a general analysis of two-port network, and what we will do, these hybrid parameters will be replaced by the hybrid parameters of transistor amplifier, and accordingly that analysis will become the analysis for respective transistor amplifier. So whenever we bring any device into application, we always connect that particular device with certain source. Here you can see Rs is the source resistance and Vs is the source voltage, and similarly there is a load. Means something which is beyond the output is always load, and something which is before the input is always source. So when it is actually brought into the practice or an application, it is connected into source and load. Let us draw the model, the equivalent circuit of this particular block diagram. Then we will analyze the transistor amplifier using this concept. But before that, let us understand what do we mean by analysis of transistor amplifier. Whenever we are interested in analyzing the transistor amplifier, we are interested to determine four important parameters. Which are those four important parameters? You can see that current gain, voltage gain, input impedance and output impedance. You can say input resistance or output resistance also. So current gain, voltage gain, input resistance and output resistance. Whenever we determine all these four parameters or four variables of any amplifier, we call that particular determination part as the analysis of amplifier. So we are interested to analyze a transistor amplifier. It means we are interested to determine these four parameters using this concept. So let us draw the hybrid model of this particular block diagram, particular two-port network which is connected to source and load. As we know that there is a standard, these two equations are there. You need not remember any model. These two equations are there. See that V1 equal to HI1. HI is input impedance. What is HR? Reverse voltage gain, as we know that. And what is V2? Output voltage. We can see that very simply. This is V1, and V1 is nothing but sum of, you can see that this is HI, where what current is flowing? I1. What is the second drop? Which is nothing but HR into V2. So equivalent circuit is so simple concept in analog circuit. In all electronic circuit analysis, when we understand how to draw the equivalent circuit, half part of the electronic circuit analysis particular concept or topic is over. So see that the input voltage is sum of HI1 plus HRV2. See that what is I2? I2 is divided into two parts, HFI1 plus HOV2. So current is always divided into parallel. So what will happen? We can see that this is our V2. What is there? I2 is current which is entering into the output port. This goes, first part 1 by HO, or sometimes we write HO also. HO is admittance and 1 upon HO is impedance. And what about the second one? We can see that this is current dependent current source. Output current is depending on input current. So how will we write that? We make one current source here, and what is the value? HF into I1. And let us connect now whatever is there, Rs and Vs, and what is there in the output side? Let me tell you, this is very important thing in analog circuit or electronic circuit analysis. Whenever we can understand drawing the equivalent circuit of any device, it means our half work is done. What we are interested here is, we have replaced our device two-port network by the model, and the device is connected externally to two things. Which are the two things? One is load resistance beyond the output, which we have connected as it has been shown in the diagram. And what is there? Another thing, source voltage and source resistance. That is beyond the input, that is before the input voltage that we have connected here. Now what we are interested, I don't think that there is any doubt in this particular equivalent circuit. When we are interested to analyze the transistor amplifier, which is common emitter, what we will simply do, V1, V2, I1, I2 will be written for common emitter. We know that VB and VC are input voltage and output voltage for common emitter. IB and IC are the input and output voltage for common emitter transistor amplifier. And what about the parameters? HIE, HRE, HOE and HFE we will write for common emitter amplifier. Therefore, it is more important to get analysis of general purpose two-port device, so that all the three configurations we can write the analysis very simply using the general purpose concept. So we are interested in what? In determining these four parameters. Let us determine those parameters one by one. So I am just removing this block diagram, and I am trying to get AI. First part is AI. What is AI? It is nothing but current gain. What do you mean by current gain or current amplification? Ratio of output current to input current. What current is flowing through the load? IL. So what I can write? IL divided by I1 is the input current. We can see that, and this can also be written as minus I2 divided by I1. What is minus I2? Because you can see in the circuit IL is in opposite direction to I2. So IL is equal to minus of I2. How can we get this? Very simply. See the second equation. What is our second equation? I2 is equal to HF I1 plus HOV2. So can we get I2 divided by I1? Yes. Because V2 is nothing but, what is V2? It is the voltage across RL. What is V2? What current is flowing through RL? IL. But minus I2 also is there. We can say it is minus I2 into RL. When we substitute V2 is equal to minus I2 RL here, and this equation will become in terms of I2. I2 will be brought this side, and you can get minus I2 upon I1 as very simply. This term will come this side, so it becomes minus HF divided by 1 plus HORL. This is the first part of analysis which is over. What is this? This is the current gain for two-port network using hybrid parameters. What is current gain? Minus HF divided by 1 plus HORL. We know that for common emitter. What will be current gain? This is nothing but minus HFE divided by 1 plus HOE into RL. If we are interested to write for common character, it becomes minus HFC divided by 1 plus HOC. If we are interested for common base, it becomes minus HFB divided by 1 plus HOB RL. In some books, you can see that this RL is written as ZL, no problem. If it is written as ZL, that is impedance. If you are writing it as RL, this is resistance. So this is the first part of analysis which determines the value of current gain. Let us determine the next value. What is the next value? Input impedance. Let us try to get the expression for input impedance. Second part. What is input impedance or input resistance? It is nothing but input voltage divided by input current. You can see in the equivalent circuit. What is the input voltage to the device? V1. What is the input current? I1. So V1 upon I1. How can we get this? See the first equation. This is written in terms of V1. V1 equal to HI1. We need to replace V2. Very easily we can write. What is V2? You can see that V2 is equal to minus I2 into RL, numerator. And what is I2? Minus I2. Minus I2 is AI into I1. So what we can write? AI I1 into RL. And if we substitute this value in this particular equation, we will get V1 upon I1. And V1 upon I1 will be, because V2 is AI I1 RL. So what will be V1 upon I1? You can see that this is nothing but HI plus HR AI into RL. What is this? This is the expression for input impedance or input resistance. If you are interested to write common emitter, for common emitter what it will become? HIE plus HRE AI into RL. If we want to know the input resistance or impedance for common base, HIB plus HRB AI into RL. So this is the second part of analysis wherein we can see that how do we determine the input impedance. Input impedance is nothing but the ratio of input voltage to input current. These are the two governing equations. Let me tell you. I mean, whenever hybrid model is there, how the hybrid model is described? That is described by these two equations. And when you have these two equations, there is nothing else in getting the analysis of transistor amplifier. Only some mathematics, KVL and KCLs are there. What is more important, let me tell you, in the analog circuit, getting the equivalent circuit and knowing the concept of some basic concept of KCL and KVL, then you would be able to get whatever you want. What we are interested to get here? Current gain. We got it. What we are interested to get, another thing is Ri V1 upon I1. What is this? Hi plus HREI into RL. The third part of the analysis is voltage gain. Let us try to get the voltage gain. Third part, voltage gain. AV. We are interested to get AV. What is AV? Voltage gain is the ratio of output voltage to input voltage. You can see in the circuit diagram. What is that? It is V2 divided by V1. What is V2? Minus I2 into Rn. Just now we have written. What is V1? I1 into Ri. See this side. Ri is equal to V1 upon I1. So what is V1? Ri into I1. What is minus I2 divided by I1? It is AI. So the standard expression for AV is AI RL divided by Ri. See that. This is the expression for AV is equal to AI RL divided by Ri. Third part of analysis is over. Let us come to the last part. What is the last part? We are interested now to get the expression for output resistance, which is very interesting. I think very interesting. Why it is interesting? Fourth part, what we are interested to know? Rho. How will we get? It is V2 divided by I2. But determining output resistance is similar to getting Thevenin resistance, because how do we get Thevenin resistance in any two-port network? Thevenin resistance is the resistance seen by the load. What is output resistance? Output resistance, I think I have removed the circuit from this particular board. You can see in your circuit that output is before the load. Load is seeing this resistance. So in the manner in which we determine Thevenin resistance, in the similar manner we will determine the value of Rho, and it is more easier to determine YO. And how can we write YO? That is 1 upon Rho. If you are interested to get Rho, that is nothing but 1 upon YO. What is YO? Output admittance. How will we get? We are interested in getting I2 divided by V2. How can we get? See the second equation. Second equation is with you. What is second equation? Second equation is I2 is equal to HFI1 plus HOV2. This is your second equation. What other information you are having? As I told you that whenever we are interested to determine the output resistance, that is determined in the similar manner we determine the Thevenin resistance. And in determining Thevenin resistance, you must be knowing that we assume all the current and voltage sources which are present in the network, and they are replaced by their ideal properties. You can see that in the circuit there is a voltage source and Rs is its internal resistance. So what will happen? Rs will immediately become 0. What about RL? RL will become infinite. This is most important thing in determining Rho. This is very much conceptual thing. Why Rs is 0? Because this is the ideal property of voltage source which we normally do in determining Thevenin resistance. And why we are substituting RL equal to infinity? Because in Thevenin concept, Thevenin voltage is nothing but open circuit voltage. What do? We make load open circuit. And by substituting these conditions, what we can write the equation in the input side? We can see that Vs is equal to, this is again 0. What is Vs? Vs is 0 because this is what will be the ideal value of source voltage 0. What is the expression? Rs. No, Rs will be there actually. If I am making Vs equal to 0, that will be 0 Rs plus, if there is some value of Rs. Rs plus what? Hi. What current is flowing here? I1. Then what next? HR into V2. See the first part of the equivalent circuit. your source voltage is written as Rs plus Hi. In both the resistances, same current is flowing, plus HR into V2. This is the third equation, and you can see now this is the expression in terms of I1 and V2. See this equation, this is in terms of I2, I1 and V2. What we are interested in? We are interested to get V2 upon I2 or I2 upon V2. We can simply substitute the value of I1. What is I1 here? Minus HR. See that? What will be I1 here? Minus HR divided by Rs plus Hi. If I substitute this value, I can get I2 divided by V2 very easily. And what will be the value? What will be the value? The value will be, you can see that I2 upon V2. This is YO. It can be written as, see that? I1 you are substituting and this becomes HO. So HO minus HFHR divided by HI plus RS. This is the expression for your output admittance. We can see that the analysis is complete. What do we mean by analysis of transistor amplifier? Analysis of transistor amplifier means determining AI, AV, RI and RO. What is the expression of AI we determine? The first expression which we determine, minus HF divided by 1 plus HORL. If you are interested in common emitter, minus HFE divided by 1 plus HORL. What was the second one? RI. What was RI? HI plus HR AI RL. You can see you have noted. Third one. What was the third one? AV. AI RL upon RL. What is the next? RO. How can we get RO? 1 upon YO. Reciprocal of YO. How do we get YO? HO minus HF HR divided by HI plus RS. If you are interested in common character, yes. HOC minus HFC HRC divided by HIC plus RS. So this completes analysis of transistor amplifier using H parameters, analysis of transistor amplifier using H model. Sometimes in some other literatures, two more things are sometimes asked. I mean voltage gain and current gain, taking source into consideration. So we will discuss AVS and AIS separately in some other lecture. I hope you must have understood the concept of getting analysis of transistor amplifier using H parameters and H model. Thank you.